I have here, this is a small little resistor, hard to see because it's so small, and this is just a practice circuit board that we've got. These tinned areas, all the places on here where you see metallic striping, that's what's going to create the circuit. So we're just going to solder this little resistor into the circuit someplace and make it part of the circuit. So when you get your actual project boards, there will be a pattern and it'll tell you where everything goes on this. Here, since I'm just kind of doing this for fake, I'm just going to stick this through a couple of holes. And the piece, whatever the component is, the resistor or the capacitor or anything else, goes on the back side of the board where there are no tin leads. And the soldering all happens on the side of the board that has the tinning on it. So we will sort of straighten these up. You want to leave a little bit of room for this. You don't want it, and what some people do is they actually will kind of bend that so that it sort of self-spaces. I don't like to do that because I just feel like I'm more prone to screwing up that way. But you will screw up. I mean, and if your resistor, you will. If your resistor's right down against the board, it doesn't matter. It's not ideal, and somebody who was a real electronics person might go, that looks terrible, but you don't care. We're not in it for appearances, we're in it for a circuit that works. So I'll sometimes put like a pencil or something under the edge of here to keep it up off the table a little bit. Here I've got a piece of wire that's already soldered to the back side of this, so that's sort of giving me a break. And this is just a piece of solder. So they come on a roll like this, and this is rosin core. This is 60/40, so this is leaded solder. I also have some lead-free solder. You're all past the period of critical brain development. You're not at big risk. If any of you were pregnant, I would say, please don't use the leaded solder. Yeah. But hoping none of you are, and I'm not. So we're just going to go ahead and use the leaded because it does flow more easily. So the tip of the soldering iron is hot, and I'm applying the tip. It's really hard to see. I'm applying it to the lead that's coming up through the board, and I'm also applying it, thank you, to the tin itself. So I'm heating up those two surfaces. You want to heat them up and you don't want to smoke them. It's a delicate balance, and you'll get better at it, and that's why I will encourage you to do some just practice on crap boards before you start on your actual projects.
You're actually doing it.
I'm actually doing this right now. It's not heating up dramatically, and this probably needs to be... Can we zoom in? I don't think you can. No. It's not hot enough yet to melt the solder. Contrary to what the one video we watched said, you do not... I always learned that you don't want to apply any solder to the actual tip of your iron because... Let's see, is this really heating? Do not test it with your hand. Yeah.
Yeah.
Yeah, I tend to not touch soldering irons. I've gotten enough burns in my lifetime. Thank you. There we go. We're getting hot now. Okay, so you'll know it's getting hot because you'll suddenly get wafts of burning rosin. And it is challenging. Now the iron is hot enough to melt the solder, but the tinning is not. And so like right now I have my iron parked, sort of touching the the leads on the circuit board and the lead that's coming up through the circuit board. So I should be heating both of those. I've got my solder close to both of those, but not touching them. Yeah, it's still not melting. And soldering it's a nice skill to pick up in general because you can use it on automotives. If you ever have to replace a voltage regulator on a vehicle, the leads for a voltage regulator have to be soldered in. So it's a practical skill. If you want to make jewelry, you can do a lot if you know how to solder, if you have silver solder. So this is slowly heating up. Okay, okay, there we go. And now it's flowing. And once it flows pretty fast. I don't know if you were able to see that or not. Suddenly, yeah, and I got that resistor pretty hot. So suddenly, the solder just melted. You know, I had it touching the paths on the circuit board, and suddenly the solder just started to flow. And it kind of happens that way. It goes from not flowing at all to suddenly like, whoa, it's flowing. And once it does that, it kind of fills that space, and now that's fully connected. I'll do the other side. I'll try to do it a little bit closer if we can. Let's see if we can reposition the camera. Oops. Well, that's repositioned. Not the way we wanted it. Well, let's see. I think if I do that, that should work, right? Okay. Is that a little bit closer? Yeah. Okay. So, once again, and now I'm doing the other lead for this resistor, I'm going to set my soldering iron where I'm touching the lead and I'm touching the pathway on the circuit board. And suddenly, well, now there I touched, I did what you're not supposed to. I touched the solder to the tip of the soldering iron. You know, inevitably you do get a little bit of solder on the tip of your soldering iron, but you don't want to. It's really hard to see that lead. Okay, there we go, and it flowed. Whoops. And I got my solder stuck, which happens. Okay, that's it. That one is done. So I'm gonna help you once you're doing it yourself. And if you look now, I cannot pull that resistor out of those holes. It is in there. It's connected via metal. So, you know, now that's not real pretty. Lots of people could take lots of offense at how ugly a job I did. Nah, you know, I haven't soldered in a year. So you trim them off. So you go all the way down to, and we have wire cutters here. You take it all the way down to just above where it's connected to the solder. You don't want it sticking out of that solder. And then you just trim them off. So what's the solder? What does the solder do? It is the solder sucker. Okay, if I had to untin a connection. So I've got my solder sucker here, and it's just a plunger that creates a vacuum. So we set it by pushing that down, and it locks. And then, you know, we've got this. And on the end here, you can see there's a hollow tip. And if you have to untin a connection, so I'll try to untin this wire that's been done here badly. So I've got the vacuum depressed. And I'm going to hold my soldering iron on this piece of wire that's already been soldered to the board. And I'm heating up the wire and the solder and the whole connection. And then when I get it to a point where you'll start to see, when you're close up, you'll actually start to see the solder kind of flow. And you may see it start to smoke a little bit too, which is, you know, not normally what we want, but it's kind of what happens. I'm sure that there is a better, you know, people who are better at this than I am don't have that happen, but I have it happen all the time. So once we get that hot, we just take the solder sucker and we literally, you know, release the plunger, and it will suck the solder right off the connections. And you can unsolder things to a point where you can now take them apart. So I just unsoldered that wire. It's no longer connected to the board. So if you screw something up, you can unsolder. Unsoldering is a pain, and it also, if you have components that are at risk from overheating, you probably can't unsolder them without frying them. So And I'll show you some of the other components that are at the most risk from overheating. So that's the basics, and let's get started.
You just slip it, you solder it.